was a fantastic insight into the E-network and also intro into IoT. I might have some more slides in a minute about showing that growth, but I'm sure you'll cope. Right, so let's have a look in a little more depth into Spitfire's new mobile solution and how it differs from our existing portfolio of mobile broadband and mobile Ethernet that Pete Oosthuizen went through earlier. So I'll come on to our product roadmap shortly. However, at launch, right now, we'll offer access to 4 and 5G for data only, but predominantly for IoT connectivity. And that'll be in the form of this triple cut SIM card that Harry held up earlier, and now I've got there you go, Harry, got the up there in all its glory. So when used for IoT device connectivity, enhanced mobile, and the fact that it's part of one network, it then starts to address some of these challenges that Pete discussed at the end of session 2. So we'll start by offering a range of different mobile IoT connectivity solutions suitable for every budget and size of project or customer. All of the solutions that I'll go through now can be supplied either with a managed Teltonika router, or they can now be supplied simply as SIM only. So to start us off on the screen, it's a pretty default solution. We could simply assign a dynamic private IP address with the device then initiating the connection to the internet and using carrier-grade NAT from the Spitfire core network. If we need direct access for remote management of a device, then we can now assign the use of a fixed public IP address. Again, as I've said, this can now be SIM only. Previously, that option was only available on mobile Ethernet with a Teltonika router. It is worth pointing out, obviously, in that scenario, your device would be completely open to the public internet, and so suitable security solution would definitely need to be put in place. And so we can provide our firewall security at the Spitfire core. Applications or users then can connect and manage their devices using SSL VPNs, and then connect to a fixed private IP address using port forwards. You might have multiple SIMs, and we now can provide you with your own private access point name or private APN. And then all of your Spitfire SIMs will then connect to this private mobile network rather than the Spitfire public APN, which is used just for general internet access. So that's going to provide you with a completely private and secure mobile network using a private IP address range with much better control of network policies and monitoring. So as you can see, we've got, or I should say it's worth pointing out, actually, we've got Spitfire have complete flexibility without any limitations in how we, of the private IP subnet ranges that we can allocate. So you can be confident that when you're designing a solution for one of your customers, that we can fit in with whatever their required private IP address scheme, or indeed if they've got an existing scheme that they want us to use. Or we could simply connect your mobile connections or private APN into the Spitfire MPLS network. So your devices can then connect directly to your cloud-hosted applications, or your users at other sites can connect to your devices, all without accessing the public internet, all on a private network. So this is one network. Dynamic or fixed, public or private IP addressing, we've got the complete flexibility. We can now create a private and secure mobile network, complete network for mobile, fixed line, and cloud. So what about the service wrap? What does it mean to that? Well, for a start, you'll be able to order these new SIMs on the Spitfire web ordering platform. We'll be able to offer reduced lead times and improved SLAs for support. Remember, these are now Spitfire supplied and controlled SIMs. So we can get them out the door and can activate them within 24 hours or less. Where we do provide Teltonika routers, those routers will now automatically detect the Spitfire APN as soon as the SIM's inserted, so there's no need for any further configuration. The Spitfire customer portal, we touched on it earlier, so it already provides a wealth of information on your existing services. So you can see everything from billing, your support tickets, your provisioning notes and updates, it's all there. And initially, for mobile, we'll offer you visibility of your entire mobile SIM estate. You'll see your mobile numbers, these IMSI numbers. You'll see the data usage in near real time. You'll see the billing, plus any data caps that you might have set on your SIMs. And of course, we'll continue to develop the functionality of the portal over the next few months. We'll bring you more features and more control. So for instance, you'll be able to set usage alerts. You'll be able to control the activation and deactivation of SIMs that you've deployed into the field. So we're initially, as I've said, going to launch SIMs, Spitfire IOT SIMs. And our aim is to offer you game-changing and flexible pricing where you're charged for the data used and nothing more. We're going to offer you short or even no minimum term contracts. We're trying to give you as much flexibility as possible and provide you with the ability to put the right commercial package together for your customers and ultimately make more margin for yourselves. So what I've tried to show on this slide, this is how you might typically buy some IoT SIMs. And typically you'd either buy a SIM with some sort of inclusive data allowance that once it's used up, it probably do one of two things. It might either go onto an expensive overage rate, so you start paying a much more expensive rate, or it might trip up to another price tier. So perhaps you've ordered 100 meg, your device uses 110, it will jump up to 200 megs, you're paying for 200. Or it might be a gig and it jumps up to 2 gig. In both scenarios, the customer will often end up paying either an expensive overage rate or for unused data. So the red line there that's our pricing model. So it's a lot more linear, and there are no jumps when usage tips over certain levels. There's no expensive overage rates or indeed paying for unused data. So we tried to make this simply as fair as possible and just charge a very, very competitive rate for the actual data used. Of course, we do recognize that some customers, they want that fixed monthly budget. And so we will also offer pooled data bundles. So if you want to assign a block of data to a number of SIMs, you'll have the option to do that at a fixed price per month. The key here is that Spitfire have got complete control over our pricing models, and so that we can work with you to provide the most suitable commercials for your customer opportunities. What about the things I haven't mentioned yet then? So let's have a look at the future developments and what our product roadmap looks like. So you've just heard from Nick about how great this EE network is, and he had a slide on there with the coverage, or the effective coverage, which I think said 99%. It's not 100%, it's 99%, but it's still obviously the reason we went with EE. It's a fantastic network. However, at the end of the day, your customer probably wants some further reassurance should the worst happen. And they probably want, or may want, at least the option of connecting to an alternative network. So our intention is to bring you a multi-network SIM to provide you with that always-on connectivity. And that will connect to the EE network as the best network and at the lowest cost. And in the unlikely event that that network's not available, then it will connect. It will go and look for a signal and connect to an alternative UK mobile network operator. And our aim in that scenario is for your data, when it goes over to that alternative network, is to remain on net for Spitfire and indeed use the same IP address configuration without the need for any changes to your IP addresses, your devices, or your network settings. When the primary network returns, the signal comes back, it will then revert back to the EE network so that you can continue to enjoy more preferential pricing. We'll introduce support for eSIM compatible devices so that you don't actually need a physical SIM card. Over-the-air updates, OTE, so that you won't even need to visit site to update certain features. You won't need to swap the SIM out. So, for example, that could be to update an already shipped SIM with single network. Perhaps you want to change that to a multi-network SIM. We can potentially do that over the air. So just moving away from IoT just for a second, I did mention voice earlier. And this MVNO it's not just about IoT connectivity, it is about other products and solutions that we can bring. So next year we will launch a competitive solution, a voice and data solution for mobile handsets and mobile users, mobile phone users. And we'll develop alongside that something called fixed mobile convergence. And that is alongside and with our existing hosted telephone system, FireSwitch, that Gary spoke about earlier. And that will provide a much, much tighter integration between the mobile handset and the hosted telephone system. So effectively, the handset is becoming an extension of the hosted telephone system without the need to install a separate application onto the mobile handset. So I thought I would bring this up. So what about low power communications for IoT devices? We've focused at the moment on 4G and 5G, and there is a lot of hype and coverage on narrowband IoT, NB-IoT, and other low power technologies like LTE-M and Cat1 and things like that. And all of these technologies, they are designed specifically to transmit very low volumes of data. They use very low bandwidths, and therefore they consume very low amounts of power. For example, it might be a sensor or a water meter, which is completely inaccessible, so you've got to stick a battery in there to keep it powered potentially for several years. And yes, these low-power technologies, they're undoubtedly going to see significant growth over the next few years. There's a slide coming up in a second. And that's especially so as 2G and 3G are getting switched off and will be phased out. So here we go. Here's some more growth figures. So sorry, I need to get some bifocals. The blue line, the blue blocks, or the greeny blocks, you can see the growth there. That's quadrupling between now and 2028. And that's globally connected devices. This graph, I should say, is published by Ericsson, and it's from their 2023 mobility report. So it's relatively recent data. The 2 and 3G is the grey stuff. So that's, as you'd expect, is decreasing to a fairly small percentage in 2028 as the low power stuff takes off. But it's the red blocks that we're really interested in at Spitfire. And that's the 4 and 5G IoT cellular connections. And that grows to about 3 billion. But the important bit in 2028, that's still about 60% of all the connected IoT devices is 4 and 5G. And in fact, according to Ericsson, they're saying the majority of those will actually be 4G connected devices. And so that is, therefore, at the moment, at any rate, the focus of our product, at least to begin with. So although we don't currently offer a low-power product, or at least on the MVNO, if you do, I've been told reliably that we can sell narrowband IoTs through our existing relationship with EE. So if you do come across an opportunity that needs this sort of technology, then do still come and talk to us, and we can get a quote and a price for you, and we can look to sell that. So, when we originally went on this journey of becoming an MVNO, it was actually to extend and enhance our existing office connectivity portfolio for voice and data. However, you've just seen on the last slide, you've seen on Nick's slides, you've seen on Pete's slides before in session 2, it was IoT that really caught our attention for its rather more explosive growth potential. So these are some of the figures that Pete talked about just before lunch, and we can see the growth, what that growth looked like in the increase of data generated and the money spent on IoT. Lots of zeros. So as this IoT adoption gathers pace, and indeed it becomes an integral part of the infrastructure of the country, all of these connected devices, they start to present some pretty serious cybersecurity threats. So as more and more cameras, vending machines, tractors, solar panels, deer, you name it. There's all these different things that are connected. They all open up potential entry points into a customer's network and are therefore susceptible to attack. We heard from Pete about the continued use of over-the-counter retail SIMs and the potential threat that is presented by those. According to another report by Palo Alto Networks, 98% of all the data currently transmitted by and handled by IoT devices, which is transmitted over the internet, isn't even encrypted. So this really does then, it leaves all these devices and customer networks open at significant risk of exploitation. So how do we go about keeping all these devices, these connected devices, secure? Well, I'll just quickly revisit some of the earlier diagrams I put up. And you think it was quite straightforward. I mean, really, from the device to the application server, you want to minimize that attack surface from a connectivity perspective. As a minimum, you want to use a NATed IP address, or preferably one of these private APNs on the mobile network with private IP addresses assigned to your devices. They could then use VPNs over the internet to connect your IoT platform, or indeed the other way for users at sites for remote management into those devices. But why not go one better and connect your IoT application without the need to even use the open internet, so that all your data traffic is only routable on a private network? There's no need for encryption. There's no opportunity for misconfiguration of VPNs or other security policies, nor indeed any attempted attacks via public internet-facing interfaces. If you really do need internet access, then obviously use a firewall, which can monitor and manage policies. It can control data flow and provide traffic analysis. You can use whitelists to secure remote access into your devices. And potentially, as we saw earlier, there's going to be thousands of these devices. And so ideally, you'd use a cloud-hosted firewall to make management far more efficient. So you can really see then how one network and all these other products that we discussed throughout the day provide the perfect ecosystem for your IoT deployment. It provides 4 and 5G mobile connectivity. It provides fixed line fiber connectivity, and then, of course, direct access into the cloud. From IoT device to your IoT platform, from your users at these sites into your devices, you're completely locking that attack surface down. Right, so to finish this session then, I thought it'd be great to show you a couple of real-world examples of one network in action. So I'm going to hand you over to Andy Duncan, who will walk you through them. Thank you very much.